Okay, let's simplify some radicals. This first one here, I see the square root of 81 x to the 6th. I'm going to use the product rule to break those up into two factors. The square root of 81 first, and the square root of x to the 6th second. Well, the square root of 81 is the number that when you multiply it by itself, you get 81. And that number is 9, because 9 times 9 is 81. Now the square root of x to the 6th, because it has a variable and the index is even, the square root of x to the 6th, I'm looking for the number who, when I square it, or the power of x, I should say, that when I square it, I get x to the 6th. Well, that number is just half of 6. 6 divided by 2, the index of this radical. 6 divided by 2 is 3, so the number that goes here, or the factor that goes here, is x to the 3rd. So I still have the 9, and then I'm taking the square root of the x to the 3rd squared, and because of the index being even, that is going to be the absolute value of x to the 3rd for the answer. And because we don't know the sign of x to the 3rd would be negative if x is negative, or positive if x is positive. Because I don't know the sign of x to the 3rd, I have to keep the absolute value. So this is going to be 9 times the absolute value of x to the power of 3. All right, and that's that one. The next one, for the next one, we have number 8, the square root of 121x to the 3rd. Once again, this is an even index. Still going to split it up to the square root of 121 times the square root of x to the 32nd power. And then I know the square root of 121 is 11, so I can work with that. But then for the square root of x to the 32nd, I have to think of what power of x I need to square to get x to the 32nd power. Once again, all I really have to do is divide the 32 by the 2 index for this radical. 32 divided by 2 is 16. So x to the 16th goes on the inside here. And that means I'm taking the square root of x to the 16th and the square root of x to the 16th. X to the 16th squared, I should say. I'm taking the square root of x to the 16th squared, in which case the square root and the square will cancel, leaving me 11, but I need the absolute value of x to the 16th power. Now, because of the fact that x to the 16th is always positive, because when you raise even negative numbers to even powers, you get positive answers. Because 16 is even, and even if you put a negative in for x, you'll get a positive answer, the absolute values are not necessary. Because x to the 16th is always positive, the answer then is just 11x to the 16th power. So that's the answer here. It's just 11x to the power of 16. And you don't need absolute value because 16 is even. And number 9. All right. So for number 9, very similar thing here, except now we're dealing with cube roots. Remember, when you're dealing with odd roots, like cube roots, you don't have to worry about absolute value at all. So you just break this up into the cube root of 27 times the cube root of 9. Oops, not 9, but x to the 9th. So the cube root of 27 times the cube root of x to the 9th. And the cube root of 27 is straightforward. That's 3 times 3 times 3 is 27. So the cube root of 27 is 3. On the other hand, here I have the cube root of x to the 9th. And I'm thinking to myself, what power of x would I need to raise to the 3rd power to get x to the 9th? What does the power have to be here? Well, 9 divided by 3 is 3. So I think this has to be a 3 here. And then I have my answer as 3, and then the cube root of x to the 3rd cubed. This cube root and this cube cancel, leaving just x to the 3rd. And once again, because the index is odd, 3 is an odd number, I don't have to worry about absolute values at all. And my answer then is just 3x to the third. 3x to the power of 3. All right. Number 10. So for number 10, let's see. Simplify the radical expression. So for number 10, once again, I'm going to split it up. And this is once again an even power. Whenever the power is even, we do have to think about absolute values. This is going to be the 4th root of 81. And this one over here is going to be the 4th root of x to the 44th power. So the first one, the 4th root of 81, the number I multiply by itself 4 times to get 81 is 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So the 4th root of 81 is just 3. On the other hand, when I'm doing the 4th root of x to the 44th, I have to consider what power of x I'd have to raise to the 4th power to get x to the 44th. The simple answer is just taking the 44 and dividing it by the index 4. 44 divided by 4 gives me 11. So x to the 11th, if I raise it to the 4th power, I get x to the 44th. Now, because this index is even, to get rid of that radical for this 4th root and this 4th power to cancel, you have to leave behind the absolute value of x to the 11th. And then, because of the fact that 11 is an odd number, these absolute values have to stay in the answer because I don't know if x to the 11th is a negative or a positive number. So my answer then is 3 times the absolute value of x to the power of 11. And that would be it. All right, and then the last one here. The last one. Okay. So I have the 4th root of 81x to the 56. Well, we've already done the 81, so we know already that the 4th root of 81 is just 3. And then we have the 4th root of x to the 56th. All right, let's see. So we then think about what is, well, we said this was 3. And then we just have to figure what is the power of x that I raised to the 4th power to get x to the 56th. So what we can do then is we can just do the division. We need to figure out what power of x can I raise to the 4th power to get x to the 56. So all I do is divide 56 by 4. 56 by 4 will tell me this is x to the 14th power that goes in here. X to the 14th power. Then the 4th root and the 4th power will cancel, and I'll get 3x to the 14th power in absolute value. But because of the fact that x to the 14th is always positive, we can get rid of the absolute value because we know that the absolute value of a positive number is the number itself. So 3x to the 14th is the final answer here. So 3 times x to the power of 14. All right, that should get you through the lecture notes, and then you guys can go ahead and do the homework for section 8.1.